This is lesson 25 on VHDL example 12, and in this example we're going to design a 7-segment decoder using logic equations. Now, in the last lesson we showed how we got this truth table where the input x is 0 to f and the output is A, B, C, D, E, F, G. We want to design a hex to 7-segment decoder. We'll call it hex 7-seg. The 4 bits are inputs, that's the x, and A to G are going to be the 6 outputs, A, B, C, D, E, F, G. So A to G sub 6 is going to be A, and A to G sub 0 is going to be G. So all we have to do is find logic equations for each of the A, B, C, D, E, F, G, and we can do that just by drawing Carnot maps. For example, suppose we wanted to find the logic equation for E, then notice we have min terms 1, 3, 4, 5, 7, and 9. So we could draw this Carnot map with min terms 1, 3, 4, 5, 7, and 9. And then we can draw the 3 circles. This one is just going to be not x3 and x0. This one is going to be not x3 and x2 and not x1. And then the wraparound one here is going to be not x2 and not x1 and x0. So here's the logic equation then for E. And we could do the same thing for A, B, C, D, F, and G. I'll let you do that as an exercise. And so once we have those, we can just write the VHDL program. The entity, the input x, is 3 down to 0. And the output A to G is 6 down to 0. And so then in the architecture we'll just write down the logic equation, sort of a mess. Here's A to G sub 6. You can verify by drawing a Carnot map. This is what A would be. B is A to G sub 5. Is this big one. 6 is A to G sub 4. D is A to G sub 3. Here's A to G sub 2, which is the E that we did, not x3 and x0, or not x3 and x2 and not x1, or not x2 and not x1 and x0. And then F would be A to G sub 1, and G would be A to G sub 0. So that's it. You could simulate it, and if you compare, we'll use a binary counter, 0 to F, and if you compare these outputs, A to G, these hex values, with the truth table, you'll see in fact that they are the same. Here's 8, which we turned off all the ones. You remember to turn on all the LEDs. So we've designed hex 7-seg with a 4-bit hex input 0 to F, and the A to G go and we'll tell which segments to turn on.